All right, we're going to go ahead and get started. Welcome, everyone, and thank you for joining us this afternoon for our Population Projections webinar. My name is Monica Cruz, and I serve as the State Data Center Lead here at the Texas Demographic Center. Before we begin, I'd like to announce that this webinar is being recorded, so if you prefer not to participate, you may exit the session and know that this recording will be available this week via our YouTube channel and our webpage. For those of you joining us for the first time, the Texas Demographic Center is the state data center for Texas, and we are a member of the U.S. Census Bureau State Data Center Network. We function as a focal point for the production, interpretation, and distribution of demographic information for Texas. An important part of our role is to work closely with state and local governmental units, as well as other statewide networks, to support their work in the delivery of services in communities throughout Texas. And the foundation of this is the use of good quality demographic data. An important part of our role, sorry about that, I'm repeating myself. Before we begin, we know that you're here because you registered to join us for our Population Projections webinar. And we're going to start, and throughout this presentation, we're going to have a couple of quick polls to just get some feedback from you about the information that we are providing and just to get a better idea of how we can better support your data needs. So we're going to start with our first poll. It is an anonymous poll, so I'll go ahead and ask our facilitator to go ahead and put our first poll up. And if you can quickly answer about, why did you join our webinar today? We're very interested to learn more about, how you heard about us or why you're here. So if you take a couple of minutes to pick your answer, that would be great. All right, we'll go ahead and close the poll now. So one of our key data products is our population projections, which we produce for the entire state and all 254 counties. And I'm pleased to introduce to you my colleague, Dr. Helen Yu, our populations projections subject matter expert, who serves as Associate Director and Senior Demographer for the Texas Demographic Center. It's all yours now, Helen. Thank you.
Thank you very much, Monica, and thank you everybody for participating today and answer our polls. And we'll have a few more later for you to participate. So this is actually the first time ever we dedicated a whole webinar to our one of our most important products, the population projections. I'm a little nervous, but also a little excited because for decades, we have been producing population projections, deliver them to the public, but after that, we kind of don't know much about how they're used, whether they're even useful, whether you have difficulties in using them, whether you have any feedback on that. So I hope today's webinar, on one hand, would provide more information about how we produce the projections, the method, and our thoughts behind them, but also opens the channel for more communications. So at least, see if we can improve our method, refine our method, and also do things to improve your user experience. Okay. So today I'm going to cover maybe a few sections. I'll first provide an overview on our population projections, and then move a little deeper into, or not deeper, and talk about basic things about our method, our assumptions, and then move to a section that may dive a little bit deeper into some of the other considerations we have and the explorations we're conducting now. And before we end the webinar, of course, we'll leave time. We'll try to leave as much time as possible for you to put in your questions and comments. And of course, in the duration of the presentation, feel free to drop your questions and comments anytime in the chat. Right? So let's start with our first section. so I'll provide an overview. I guess the first question, kind of the one that your teacher probably asked you to say, talk about population projections as if you're talking to your grandma or something. This is actually pretty hard, but I found a very good quote from this book, A Practitioner's Guide to State and Local Population Projections. I think it's simple enough and very clearly state what projections are. So they are conditional statements about the future. Two keywords here is the conditional and future. So in that sense, the population we produce are actually conditional statements, which are expressed in numerical statements, numerical numbers, which is the projected populations. And these projections are based on a certain kind of conditions in the future we make assumptions on. We don't know all the future, but we have to say, assuming future conditions is like this is our projections. And so understandably, the further the future conditions deviate from what we assume, the more wrong or less accurate our projections are. So it's very important to understand that, because that will help your decision making. I'll just take a very simple life experience when my daughter says, oh, I think I'm going to become Elon Musk, so I can start spending tomorrow. I probably wouldn't buy that much into that, right? But on the other hand, if she says, well, yesterday it took me this time to finish this homework, and today is a very similar homework, I think I'm going to take the same time. I probably will think there's more value to that and make, relative decisions based on that. So today's webinar, therefore, is really to show you as much as the method as the assumptions we make, so you can make that kind of judgment to see whether it's appropriate for your decision making and your use of the data. And of course, when we make our assumptions, we don't assume that we will become Elon Musk. We do put lots of thoughts into that. So our assumptions are made first, of course, by looking into patterns from the past, looking into historical data. So our assumptions are data-driven, and our assumptions are informed by the most current research and data in the demographic field. We are members of the American Association of Population. We are very active in all kinds of state collaboratives with the Census Bureau, with other state researchers. So we try to stand at the front of the research to be informed on those knowledge. And we also evaluate and adopt perhaps the most widely used model that are currently used by the United Nations, the United States, and many other states in the US to project population. And then before we go to talk about those assumptions and methodology, let me first provide an overview of what we provide to you once we have our projections. So our projections are total population and population by age, race, and sex for Texas, and all its 254 counties in Texas. So currently we're not projecting at the place level or city level. So we also provide single year of age, and currently 5 race ethnic groups, that is Hispanic, and all these other groups are non-Hispanic. They are non-Hispanic white, non-Hispanic black, non-Hispanic Asian, and finally a residual group, basically everybody else except for the 4 major race groups. And the projection horizon is from the most recent census, the 2020, and out on to 40 years in the future. And currently it's of course 2060 if our launching year is 2020. And with that, we also have 2 sets of projections based on 2 migration scenarios, and we'll talk about those scenarios more later. And when are these projections available? So we produce them every other year, and they're usually released, a normal schedule in the fall of even numbered years, meaning like 2018, 2022. And our latest version is, of course, vintage 2022. It was delayed, was actually released, I think, in early 2023. Lots of delay were not to blame on the Census Bureau, but it was largely due to the delay in release of the 2020 census. And also because of those delay, this time for that vintage, we didn't provide lots of demographic details, especially not at the county level. They are currently available, this vintage currently available on our website as in the format of downloadable files. And the upcoming vintage 2024, and that's where, mostly why we're here today. We're kind of in the research period. We are starting to look more into this, and soon we'll begin the production. But we plan for it to be released this fall, possibly by the end of November. And for this version, we do plan to provide all the demographic details we used to provide: age, race, ethnicity, and sex at the state and the county level. And there will be, of course, you'll be able to download the whole data files. And also this time we'll make the custom table available, meaning you'll be able to choose the exact race, age, and sex and county only to your interest. You don't have to download the whole thing. And so the next thing is, so how are our population projections used? As I said, we unfortunately don't know the entire picture of how our projections are used, unless if we learn from you, right? If you tell us. But we do know, maybe these are just some of the examples. An important note to put in here is that these projections are not a definite prediction of the future. So when you use that, just keep that in mind. And but we do know that people utilize the projections, and more often than not modify them based on their own needs to enhance their decision making in practical situations. Situations like planning for infrastructure. I think lots of these are for planning because it's for the future, right? But here I'm referring to like water usage, transportation needs, that kind of infrastructure building. And they're used as denominator for prevalence rate or enrollment rates, like the prevalence of diabetes, the enrollment rates for Medicare, that kind of thing in the future. And they can also be used as allocation factors across county. If you have funds, state funds as a lump sum, you can use our county chair projected one to allocate your fundings that way. And they also can be used as input for other forecasting models. For example, the travel demand model. In there, so what we project is residential population, but you may need employment, you may need commuting patterns, and this can be our residential population projection can be part of your input. And also, we also heard people using it as growth rate for budget planning and benchmark for local projections. Let me look at yours and see if I can produce my own place projections or city projections. And last but not the least, people use it for grant applications. And so we really would like to hear your use or what you think can be used. And you can email us, but at this point, coming up the poll 2, tell us now. Tell us now how you think or how you use the projections. And if you know anybody else who are using the projections for certain purposes. And if you don't see anything that's similar to yours, write down your answers. We have an open-ended question at the end. Okay, thank you very much for your responses. Like I said, if you didn't have enough time to do it, drop us an email anytime. We do want to learn from you. Thank you. And then we'll move on to our next sections. get this out of the way. So the method and the assumptions. So this is the section we talk about our basic assumptions and the method we're using. And so talking about population, I think you may or may not know, probably the most accurate population counts when you see our populations, this and that, actually came from the decennial census. For example, in 2010, the decennial census, and supposedly every household in the United States are counted in the census. This is not a sample survey, this is a full count. That's why it's considered the most accurate population numbers. In 2010, we have a little over 25 million population in Texas. And 10 years moving forward, we added about 4 million. And so that's according to the 2020 census. And now we have about 29 million population in Texas. Any time between these two censuses, when you hear, populations, there are usually some kind of estimates and some kind of survey. So these, the decennial census are considered usually the most accurate counts of population. And so one way we can do projections is to, we know last 10 years we added this 4 million. So 2030, I think, we'll add another 4 million. This is your simplest way perhaps to do projections. Or you can say, oh, I think it's not the numbers. We can grow, like the growth rate will be the same as last decade, which is about 16% or annually 1.6%. We'll have a growth rate and extend that to 2030. And so you get your projection that way. And lots of people do that. This is probably another simple way to do it. But for us, we think that we can add more to it using our knowledge. Because we know in our demography, this 4 million people, we call it population change, right? It can be negative or positive. For years, we have been positive. This added population can be further decomposed into at least two parts, right? Natural change, which is birth minus deaths, and net migration, which is in-migration minus out-migration. Right? And we call this components of change, population change. And when you think about it, there's many things that can affect population change, can affect birth deaths, can affect migration. But these are actually the only components through which all these factors like employment, social norms, all these things can only work through these two processes or these several processes to affect populations. There's really no other way. So if you write it in a formula, you don't even have an error. There's really no other way so far as I know, that population can change, except for natural change, birth minus deaths, and migration. And so then the projection in the future becomes like this. If you use that kind of approach, so future population then equals the current population, which is the 2020 census, right? And so instead of directly projecting the population, which can carry errors, right? We use something, the current population count, which is already pretty accurate. Plus, now the only thing we need to do is project change in the future, which is composed of, as I mentioned, projected birth, projected death, and projected net migrants. Okay? So then the task for us become the projection of population change, not a direct projection of the population. And so we call this method cohort component, and this is the components came from here, the components of population change. And where did the cohort come from? We also know that age is we do so these birth, deaths, and net migrants change from cohort to another. The change rates and the way they migrate is very much affected by age. So we go through this process separately for each birth cohort. That's just a fancy way to say, by age. Okay, and so this is in a very simple way the illustration of how we do what our method is. And so now I'm going to go through one component after, after the next, each of the components, and talk about how we construct them, right? So I mentioned current population just means, we usually start with the 2020 census count. And then how about the births? So instead of saying, hey, last 10 years we have this many births, we think it will be better if we try to find the rates, because I probably don't need to convince you that the number of births that you have in a society depend a lot on how many childbearing age women you have, at least now currently, right? Before we know how to produce babies in factories. So the female population and their age structure really decide on how many births they have. And so, so instead of calculating the births, we try to find the rate. So ASFR is actually the age-specific fertility rate, as shown in this chart. So this is a chart where your x-axis is the age of the women, of the female. And then, and then the y-axis is how many children you have at each age point. Of course, on average, we won't have a baby every year. In fact, in many years during the childbearing age, you have a lot less than one, right? For example, even at the peak age, you probably only have 10% of chance of having a baby if you average them out, right? So, this is the age-specific fertility rates, and you can see also from this chart that they differ by different group of people. Here I'm charting the race. You can see that when you look at the orange, the NHY population, they peak at a different time than, say, for example, NH black, which is in gray, right? The peak for NH black is not as high, but they are wider or across more age period. And NHY, they peak at that center, but the peak time doesn't last long. So basically, they follow a different shape. And then furthermore, Hispanic, so they are higher in general and also last longer. This is Asian population. They have a very sharp peak, but other ages it's very narrow, meaning that they have less chance. Their childbearing is really concentrated in certain age group there. So basically this shows you like instead of doing like let's try to have everybody the same age specific rates, it seems that race ethnicity we should do them separately by race ethnicity. And so that's when we look back into the past. This is data from 2019 and 2021. These are the patterns we identified, right? And so we think it will be better if instead of projecting or looking at total fertility rate by age, we can also do race-specific, age-specific fertility. That will improve our accuracy. So that's one of the things we saw. And by the way, I put in here, there's also a concept of TFR. So we see the shape now. How do we know who has more babies here? And so if you look, actually, if you calculate, add all these up through the areas under the curve, you actually get TFR, which is a concept we use to measure almost like an aggregate level of fertility. And so look at the annotation on the right. So it can basically be understood as the number of children that will be born to a woman, and with all the small print there, if you follow this pattern of childbearing, okay? And so this is usually an indicator of fertility level, the general fertility level. And so you probably have heard about 2.13. This is really the number of children you can have as indicated at the data, And so we now know, all right, age, race, ethnicity is important. We would do them separately. And then the other thing we also looked into, and not everybody does that, is that we think regions differ too. This is where we look at rural-urban differences. We were informed by literature in the field that rural-urban status may affect where you're living, may affect how many children you have. And so this is another research we look using past data, and we found that so on the axis is the rural-urban influence code. Basically, the higher your number, the more rural the county is. And if you look at, it seems to follow a pattern where the more rural the county is, it seems that the TFR is higher. And so we feel, okay, so the data is showing us maybe we should also separately evaluate fertility rates by the type of counties, right? We group counties into this several categories and project them separately. Okay, and once that's done, so we looked into the past. Now it's time to look into the future. How do we project future? We can say, let's keep them constant. Well, we think, our fertility rate will remain at, for example, 1.78 or 2.1 now. But instead, again, we look at past trend. The fertility actually remained constant for in the last century, actually, last half of the last century. But recent years, we did see this kind of declining trend. And this is when we try to draw, or not draw, but try to find a trajectory. And I think this is how TFR is going to change. We think that the TFR will continue to decline, although the pace will be slowed down and maybe plateau at a certain point. So this is how we based on, again, on past trajectory and then project into the future. I'm only showing you the total TFR, but we actually did it for all the race and rural urban county groups that I mentioned before. So each one has their own trajectory going there. So that's, in a nutshell, how we did our projected fertility rates. To sum up, as I mentioned before, the assumptions as important as the method. In this projection, we assume that total fertility rates will continue to decline, the last chart you see, but at a lot slower pace. The age-specific fertility rates will be stable within each race ethnic group. The rural-urban differences in fertility rates will persist. Again, I want to reiterate, these are all assumptions, and we know that these assumptions seldom turn out to be exactly the same. And usually, and of course, the more different the future is going to be, the less accurate our projections would be. So, and so that's births. Very similarly, we look into the death data in the past. And I said here population times death rate, but instead we actually directly calculate survival rates using a tool that demographers often use, the life table. Through life table, we are able to calculate the survival rates by age. Again, I don't need to convince you, and you all know this, that survival rates or death rates actually very much affected by age. Age is the single most important predictor of survival rates, right? So it's important to calculate that by age. As you can see, again, this is the trajectory of NH-white population. So few deaths until you get to maybe middle age, and really lots of deaths after you get older. And again, we see similar patterns, or not similar differences across race groups. And so this is the NH bag. Their survival rates are not as good most of the time, but there's an interesting and famous phenomenon here. Somehow, if they can survive until 86, their survival rates actually get better after around 85, 90. So, and furthermore, we see probably a Hispanic. This is, if you have heard about this Hispanic paradox, where you expect Hispanic may be having a a less good life expectancy, but they're actually very similar to the non-Hispanic white. And this is the NH Asian population, which is probably having the best survival rates across the life course. So this is male, and but you probably have heard that male survival rates are usually, in general, not as good. Almost at every age level is not as ideal as the female survival rates. So it's very important to project them separately by sex. So basically, we also see some of the similar patterns in the female survival rates. And so once this is done, again, similarly as we do earlier, how do we project in the future? This time we borrow something from the Census Bureau. Census Bureau do their own projections, and they project a life expectancy trend here. This is almost like a summary statistics of all the age specific survival rates, right? So in their projections, they project that the life expectancy or survival rates will continue to improve in the future. The gap will remain between male and female, but maybe shrinking a little bit. So since they've already done the job, we borrow their trajectory. Basically, we are saying, and Texas is a little different. It has a little lower life expectancy than US. And we want to keep that. So basically, we're keeping our own life expectancy and survival rates, but assume that our improvement rate, so this kind of improvement, will carry in the future. So basically, you will see this parallel line of Texas along with the US throughout the projection period. And so for this one, because you can already see earlier when I show you the survival rates, the data can be really volatile when you come to single age. And so in this projection, we actually use the state survival rates for all the counties. We didn't distinguish county life expectancy. So again, to summarize, for our survival rates and death projection, these are our assumptions. Life expectancy and survival rates will continue to improve and will follow the pace of the nation as projected by the Census Bureau. Age and sex-specific survival rates will be stable within each race ethnic groups. Counties will have the same survival rates as the state. And so the last one, this is the most difficult one. So we probably all know this migration can be affected by lots and lots of factors. It's very hard to pinpoint a few, factors. And more importantly, it's very hard to form a model because each region is different. Every time it's different, every time period. So one approach, and first, before we go there, then let's talk about this. How we try to, even calculating migrants or trying to define who migrants are is a difficult task. So here we're basically measuring migrants by saying, if you live at this place, for example, one place at the beginning, for example, 2010, now 2020, hey, you have moved into a different place, then you're a migrant to the new place, right? We can't, and we probably cannot define how many times you have moved back and forth, or whatever, or other places. But here it's really defined by the starting and the end point, which in our case is 2010 and 2020. So that's how we define migrants in the first place. And instead of calculating in and out migrants, we actually really just simplify it by net migrants. And this is obtained by, again, looking back, remember our population components of change. So we calculate the population change between 2010 and 2020 and take out all the increased number or decreased number from natural increase. And any added population or decreased population then would be your net migrants there. We think any population change that's not caused by birth or death is migration. And of course, we won't be able to tell in this method who is moving in and out, but just a net, which is in minus out. And again, instead of using the net migrants to project in the future, we use net migration rate. And this time, instead of figuring out a trajectory, I'm going ahead from me, and and here's an explanation why we chose this method. The reason being, this is a very simple method that only uses decennial census. The data source is simple, and they are very reliable. And also the other source is the vital statistics. These two data sets are actually the most reliable, one of the two of the most reliable data sources about population. And so it also can be applied to all the subpopulation groups: age, race, ethnicity, and sex. Remember, we talked about how important they are in predicting fertility and mortality, and of course, migration. Right? So, and the other beauty of it is that it can be applied to all the geography that Census Bureau collect data on. Like county level, like place level, and state level, of course. And also because census has been conducted for many, many years, centuries, right? And we have been really collected vital statistics for many, many years too. And so we are able to find data, historical data and relatively consistently across time and across geography. And so these are the advantages of using this method. And so how about future? We know from this calculation, this is when we calculate the residual migration rates. We compare 2010 and 2020, then calculate the migrants after taking out the natural change. This is the migration, and then divided them by the population. This is the migration rates we got from that method. So you can see that they do differ again by age and race. You probably see, lots of migration from the Hispanic population there across, again, a wider span of age. But for NH Black and NH Asian, it only peak at the maybe college age and then also earlier career age. So really interesting patterns you see across. And so instead of then this time to project a trajectory, this time what we do and what many demographers do is to assume these rates will carry throughout the projected years. We're not going to do any trajectories. We'll assume, so this is where the two migration scenarios came from. We'll assume that the migration rates between 2010 and 2020 hold throughout the projected, which means the same. We'll use the same migration rates throughout the projected years. And then we produce another scenario, assuming that the migration rates are half of those between 2010 and 2020 throughout the projected years. So this is our another migration scenario we provide for you. And so, and then once all these done, we put them in this big model. We start again with 2020 population, age 0 to 95. We add or we minus deaths, or really get the survival population, add the net migrants, age everybody here to, by age 1. And then we added population 0, which came from the projected birth. And now moving forward 1 year, you have your projected population 2021, and then the whole process start. And then we carry it to 2022, 2023. So this is how we put everything together. And from here, you can see this way, when we do it year by year, it really accounts for all the cumulative effects of population, which you also often hear about momentum, right? When, for example, when you have a decline fertility, you will, 20 years in the pipeline, you will have fewer maybe women in childbearing age, and then that will affect how many births you have. this way, you are catching the impact of population change along the way throughout the years. And so this is another beauty of the cohort component method. And so once this is done, we of course do lots of evaluations on the reasonableness of the rates. We replace outliers, extreme values, with other more stable values from the state numbers, broad age group numbers, or county totals. And the important thing is also we do these projections by race ethnicity for all the counties in the state. And then once that's done, the county sum usually do not add to the state totals. We control them so that they will add to the state totals. The assumption behind this is state projections are usually more stable than the individual county projections. And one note is that by using age, race, sex, and county-specific rates in most of these processes, these factors are actually implicitly the predictors of all rates. Okay? So not only will we be able to produce population by age, race, and sex, and the way we're doing it make them important predictors of all processes. So now comes the poll 3. We want to know how, what data you think will be useful to you. What kind of geography, what kind of demographic details. All right, thank you very much for answering the questions. And let me move quickly to, like I said, I'm glad I have covered all the basics, right? Maybe only going through a few projection evaluations. So they evaluate our last projection produced before 2020 census. And that's how we usually evaluate our projections, by comparing them to the most recent census count. And this is how we did. We were different from the census by 1.8%. And then we also learned later that Texas could have been undercounted by 1.9%. So if you take that into consideration, we're actually right on point with our projections. So our projections of last vintage, the 2018 vintage, was pretty accurate at the state level. And of course, this is our new projection. And so the slides will be available to you later, and you can look at some of these, but I do want to jump onto this one. So far you probably have heard, we have 2 migration scenarios. I never told you that we have, eras or anything like that, which many people ask. So this is something we're exploring now. So instead of having what we call deterministic kind of projection, which is this formula you saw, this is definite, there's only one number, or two sets of numbers of different migration scenario, we're exploring ways of doing probabilistic model, where we will provide you and we'll let you know how accurate, well, I don't know whether we'll let you know yet on this vintage, but we're exploring whether there's a possibility of providing you with a range or probability interval of where the future population will be. Basically telling you, if you fall in between those dotted lines, you're 95% of the time, the population will have 95% confidence that your future population will fall in between that dotted lines. So very similar to the margin of errors, which some of you may be familiar. And so here, because I want to get this poll in, we want to know from you, would that be something helpful to you? Okay, thank you very much. Okay, so I think I have some FAQs put here. I've already provided the answer. You can review those. Hopefully that helped. Before we go to the Q&A section, I want to put this plug in. So we'll have our conference, annual conference, May 29th and 30th. This is the QR code you can scan to find more information. And with that, I'm going to move on to our last section, questions and comments. And I'll transition this to Valeria, who has been monitoring and will be monitoring the chats and all the Q&As.
We do have a question in the chat that I can read out.
Okay.
It says that I see the State Water Development Board has produced population forecasts for places that they use in their water planning. Were those forecasts supported by the TDC? And the second question is, does the TDC do forecasts for places?
For the first question, yes, I believe TWC use our projections as their launching point, and then they do their own adjustment. Second, currently we don't, but we would be happy to look into that, especially if you want to, consult it with us, or we can collaborate on those. Thank you.
Another question in the chat. How do the abortion laws from the US and Texas affect your fertility rate projections and data? And how do you/can you account for this?
So I skip a slide there where we talk about unpredicted or events that you like can have an impact. The first thing is we haven't had enough data to evaluate the impact, like what you're asking. So we probably will monitor the fertility rates, the birth rates, and then see if we can identify patterns and see if we can determine the impact of that, and then maybe determine how we can handle those. But currently, no, we are not, at least not incorporating that. And I don't see, it's unlikely that we'll be able to include that in our next vintage. So.
And then last question in the chat, this one's a bit more specific. It asks, how can the TFR be calculated by regions with the DHS dataset?
So that's actually perhaps a pretty, I can, if you reach out to me later, I'll provide the emails, send an email to TDC. I'll be happy to help you with that.
And then Sarah Imran has raised her hand, so you can go ahead and unmute yourself to say your question.
Hi, sorry, I just had a clarifying question. I didn't want to take all the time typing. First of all, thank you all so much for this webinar. It was really insightful, really fun to learn about all of this. So thank you. I asked a question about how abortion laws can affect your projections and your data. And I'm just curious, genuinely, just out of curiosity, how long does it typically take for you or any other, research entities? How long does it typically take for you guys to be able to study the effect or the impact that certain laws like this have on, these projections and data, whether it's abortion on fertility rates or immigration laws on migrant rates, if that makes sense. I'm just curious how long it usually takes to see that impact.
So I think it depends on that. And I think there are also this aspect of academic research versus applied field. I'll not comment on academic research, but in terms related to our projection, one thing I would say is, as I mentioned earlier, lots of things can affect fertility, right? This is usually not so like I said, our data really, if you look at all the things I talked about, I didn't put in social norms there. I didn't put in income as our predictor. We look at things as this. We think the natural increase, like the natural change, is a result of all these factors. If you see the impact, a decline of fertility, it's the result of all these policies. Academically, they're very interesting what's affecting it. But in the applied field, we actually can look at the change. If the fertility increase or decrease because that, it will be captured. You saw that, right? In the trajectory we saw.
Right.
Does that make sense? With that, and if we see, abnormalities, for example, we see suddenly you see a dip in the fertility that's abnormal than other times. And for example, let me take a pandemic as an example, perhaps, because that's easier to detect in your thing. You had a dip in that fertility, and then later you found, oh, okay, it came back. That's the effect of the pandemic. And then you can then take this scenario to say, in the future, there's a pandemic, it probably will follow this. But if there's not a pandemic, it will follow this. This is how we usually handle that.
Yeah.
So,
Okay, makes sense. I also just quick follow-up if I can.
We do have one more question, if that's okay. Is that all right, Sarah? If you don't mind sending your question via email, we just want to make sure we get to a couple of other questions.
For sure, no problem. Thank you again.
Thank you for asking. Thank you so much. Our next question, I'll just jump in for Valeria, so that we can go ahead and end our webinar here. We have a question that says, what cities are most impacted by migration trends through 2060?
wow, that's a good question. As I mentioned earlier, so could you repeat that question again, Monica?
What
Which cities
are most impacted by migration trends through 2060?
So, like I mentioned earlier, we don't do city projections, but I can talk about areas in general, because we are using the past to project the future, right? The migration rates are, we kept it at the same level last decade. So it would be the areas that were most impacted in the last decade, which is really what we often talk about, the triangle areas in the Dallas-Fort Worth, Austin, San Antonio, and the Houston areas, especially the areas surrounding the suburban rings surrounding them, like Collin County, Tarrant County, and in the Austin San Antonio area, the Comal, and then perhaps the Hays County, that will see lots of impacts from migration in the future.
I think that concludes all of the questions in the chat, Helen. I don't know. We have one more last poll if you wanted to post it on, just to get, we wanted to get a little bit of feedback if you want to go back to the last poll. And we just, first of all, we just want to thank everyone for joining us here today. We really appreciate it. This is where our attempt to kind of provide a fundamental basic overview of population projections. And it's really hard sometimes to gauge the knowledge base of all our users, but we always think it's good to do a refresher and do a fundamental overview. So I really want to thank my colleague, Helen, for this great presentation. We ask you to please answer the poll, take a few minutes to answer the poll here before you. And this pretty much concludes our populations projections webinar. We really thank you for joining us. Please don't hesitate to reach out to us with any of your data needs or any follow-up questions that we were unable to get back to you on or to answer during this presentation. We really do want your feedback and want to be able to answer your questions and also provide the best data products for you. So I think, Helen, if you wanted to put up your last slide with your contact information. And we just want to, again, thank everyone for joining us today. And this concludes our webinar. Thank you, everyone. Have a great rest of the week.
Thank you.